In this video, we're going to talk about the relationship between factors, intercepts, and solutions. So say you have a function here, 2x cubed minus 3x squared minus 11x plus 6. So if we look at the equation or the graph, we can see that there are intercepts at -2, 0, 1/2, 0, and 3, 0. What that tells us is that if you plug -2 into this equation, you get out 0. So f of -2 equals 0. Also, f of 1/2 is equal to 0. And f of 3 is equal to 0. What that means, I won't do all three of them, but what that means is if you were to replace all of the x's with -2, the answer would be 0. Therefore, if you were asked to solve the equation, the solutions are x equals -2, positive 1/2, and 3. Okay, so far we have the x-intercepts and the solutions if the equation was equal to 0. The last thing that we need to do is put it into factored form. So let's just one more time. I erased it. We have -2, 0. We have 1/2, 0. We have 3, 0. Because of the zero product property, we know that one of the factors is x plus 2. I know one of the factors is x plus 2 because it doesn't matter what the other factors are. If this factor were to be 0, then the product of those factors would be 0. Another factor I know here is x minus 3 for the same reason. If x were 0, or I'm sorry, if x were 3, this would be 5, but this factor would be 0, and 0 times anything is 0. The last factor, 1/2, you could follow the same pattern and say it has a factor of x minus 1/2. You also could write this in factored form as 2x minus 1, x minus 3. If we look at the function in standard form, we can see that the leading coefficient has a 2x cubed. So we know that this is the proper factorization because this would have a leading coefficient of 2. So therefore, once again, the factors we did right here, those are connected to the x-intercepts. So we got each of those factors by saying what would I plug in to make those x-intercepts. And then, of course, if you were asked for solutions to when the function is equal to 0, you would have the same 3 numbers here as you have for the x-intercepts.